Hello everyone and welcome back to another calculus video. In this video we are going to look at another integration technique called integration by parts. I like to call this a last resort theorem. If you've tried all other options and you've tried U substitutions and U substitution doesn't work, maybe looking at and comparing to um, an inverse trig formula and it's not working even with some tweaks like completing the square, then maybe by parts will work. Remember, not every um, expression is going to have an antiderivative. There are some things that don't, and we'll talk about those later in the course. So here's what integration by parts says. If you have an integral of u dv, it's going to be uv minus the integral of v du. So what happens is you get to pick u. dv is the leftovers. And then if you know u, then you know du because you just take the derivative of it. If you know dv, then you can integrate it to find v. Now the key is picking something so that this guy is something that you can integrate. So what are strategies for picking u? You can remember this acronym to help you figure out what you should pick for u. LIATE. If there's a logarithmic part, try picking the logarithmic part for your u. If there's an inverse trig part and not a logarithmic, then try the inverse trig. Is there an algebraic part? Pick the algebraic part. What about just a regular trig part or an exponential part? So you would just kind of go through that order. So let's look at a few examples here. Let's say we want to integrate x e to the x dx. We don't have a formula for that. We could try a u substitution, but a u substitution isn't going to get us anywhere. This is where by parts is going to come in handy. So integrating u dv is uv minus the integral of v du. You've just got to pick out what your u is going to be. So if we go through that list, we do not have a logarithmic or an inverse part, but we do have an algebraic part. And what that means is you have some kind of like x to some power function. So let's try that. Let's let u be x. So if we let u be x, dv is going to be what's left over. And dv would end up being that e to the x dx. And now that I've picked this and I've decided what the leftovers are, I can find the other two pieces. I can find du by taking the derivative of x, which is 1 dx. And then I can integrate this to find v. And if I integrate e to the x with respect to x, I'm going to get e to the x. So this is in the form of u dv. So then the formula says it's going to be u times v, so x e to the x, minus the integral of v du. 1 dx is the same thing as dx. So to finish this problem off, I'm going to have to integrate that e to the x, and we know when we integrate e to the x, we're going to get e to the x. So there's my antiderivative. Remember, we can always check our answer. Let's take the derivative of that. If I take the derivative here, I would use a product rule. First times derivative of the second, which is e to the x, plus second times derivative of the first. The derivative of e to the x is e to the x. Derivative of a constant 0, and you can see how this is going to leave us with x e to the x, which is what we started with. So you can always check your answers on a test quiz or final exam. So I got another example. Let's say we want to integrate t ln of t plus 5 dt. We're trying to figure out first what u is. So notice we've got a logarithmic part. So I'm going down that order there, L-I-A-T-E. So I'm going to choose u. So I'm going to let u be that logarithmic part, ln of t plus 5. So that means dv is what's left over. If this is u, then dv is going to be the t dt. It's the leftovers. From there, we can find du, the derivative of that ln. Remember, derivative of ln is du over u. So that inside function is t plus 5, and the derivative of that would be 1. We took that derivative with respect to t. And then if I integrate to get v here, when I integrate t, I'm going to get t squared over 2. So this guy, t ln t plus 5 dt, is going to be uv. So t squared over 2 times ln of t plus 5. Remember, I can multiply things in any order. Minus the integral of v du. So let's simplify what's going on here. I'm going to pull that factor of 1/2 out. uv minus the integral of v du. I forgot the fraction there. Sorry about that. So I pulled that factor of 1/2 out. So now I've got the integral of t squared over t plus 5 dt. We've got to simplify this. This is a top-heavy fraction. It's an improper fraction. The degree of the top is bigger than the degree of the bottom. So remember, we would have to do long division on that. So I'm going to divide into t squared. T goes into t squared t times. If I multiply back through, I'm going to get t squared plus 5t. So when I subtract, the t squareds are going to cancel. Remember, this t squared is really t squared plus 0t plus 0. And when I figure out what my remainder is, 0t minus 5t is a negative 5t. Now we're going to do division again. T goes into negative 5t negative 5 times. Multiply through, negative 5t minus 25. Subtract. My remainder is going to be 25. So this guy is the same thing as quotient plus remainder over divisor. So notice I'm writing complete mathematical sentences here. This is very important. You have to write complete mathematical sentences. So this guy is equivalent to t minus 5 plus 25 over t plus 5 dt. So I have minus 1/2, and then we're going to integrate this. When I integrate, I'm going to get t squared over 2. When I integrate the negative 5, I'm going to get negative 5t. And this is going to be ln, so 25 ln absolute value t plus 5. And then we're going to have plus c on the end. And then we're going to clean this up just because it's really messy. So t squared over 2 ln of t plus 5. I'm going to distribute that 1/2 to everything in here. So that's a negative t squared over 4 plus 5t over 2 minus 25 over 2 ln absolute value t plus 5, and then plus c. So there's my final answer. Let's look at another one. Let's say we want to integrate x squared, cosine of x dx. So thinking about that list order of how I pick u, I'm going to start with that algebraic part, x squared. So we're going to let u equal x squared. So dv is what's left over, integrating that's going to be cosine of x dx. So I've got my u, dv's leftovers. Now I'm going to identify du, the derivative of what I picked for u, is 2x dx. And then if I integrate dv to get v, integrating cosine, we're going to get sine of x. So this guy is equal to uv minus the integral of v du. So I'm going to clean this up. We've got x squared sine of x. I'm going to pull that 2 out. I'm going to rewrite this as x times sine of x. Now, we don't have a formula for x sine of x, do we? So this is a key to let us know we're going to have to repeat integration by parts. It's possible that you'll have to repeat it 1 or 2 times or more. I've seen it happen more. So let's choose a u. We're trying to integrate this guy. So again, we're going to pick the algebraic piece. So dv is going to be that trig piece. It's the leftovers. Let's pick du. The derivative of x is 1 dx. And then if I integrate to get v, when I integrate sine, I'm going to get negative cosine of x. Now this is just for integrating that x sine of x dx. So our answer here is still going to have this, and whatever this is going to be multiplied by that negative 2. Make sure you write complete mathematical sentences. So I've got x squared sine of x minus 2, and then I'm put a bracket here for my integration by parts for that piece. So it's going to be uv, so that's going to be a negative x cosine x, minus the integral of v, negative cosine of x du, which is dx. So I'm going to get x squared sine of x minus 2 minus x cosine x. I'm going to pull that negative out to make that a positive. And then we're going to integrate that cosine. And then we'll clean this up. So just like order of operations, let's work from the inside out to make life a little easier. When I integrate cosine, I'm going to get sine. It's a positive sine. And then we're going to have a plus c. And then now I'm going to clean this up by distributing that too. So this is going to be x squared sine of x plus 2x cosine x minus 2 sine of x plus c. There's my final answer for that. So you can see how this process, if you have an algebraic piece, could get a little complicated. What if this were a 3 or a 4 or a 5? Then we would have to do integration by parts even more times. If this were a 3, we would have to do it again. If it were a 4, we'd have to do it 2 more times. So there is a tabular method. And it works when U is an algebraic piece. So let me show you that. So we're going to have a column for sines. We're going to have a column for U and its derivatives. Then we're going to have a column for dv and its antiderivatives. So the signs are going to alternate plus, minus, and so on. We'll have to figure out how many rows we need. We're going to start with u. U is the algebraic piece x squared. The derivative of that is 2x. The derivative of that is 2. And that algebraic piece, its derivatives will always end up going to 0. That's why this works so well. So I'm going to need 1, 2, 3, 4 rows. So I'm going to continue my pattern of plus minus here. And then dv, remember dv comes from the leftovers after you pick u. So dv was cosine of x. So then we integrate. If I integrate cosine, I get sine. If I integrate sine, I get negative cosine. And if I integrate negative cosine, I get negative sine. So here's the way the tabular method works, how we're going to read this. So we're going to multiply here, and then we're going to go down here. Across and down. Across and down. And you can see how if we did this again and we went across and down, we'd be multiplying by 0. So that's why you stop when you get to 0. And then we're going to have minus 2x times negative cosine, which will be a positive 2x cosine x. And then we're going to have a positive 2 times a negative sine, which is a minus 2 sine of x. And then plus c. And you can see how that's the same thing that we had above here. So, like I said, the tabular method only works when you have an algebraic piece. Let's do another one just for fun. Let's say we want to integrate x squared cosine of x dx. Let's do x to the fourth here. So this one would require by parts 4 times. I am going to move this piece down here so I have more room to do this. Let's use that tabular method. So again, we're going to have sines. We're going to have u and its derivatives, and we're going to have dv and its antiderivatives. That means we're integrating that. Sines are going to go plus minus plus minus. We'll figure out how many rows we need. U is going to be the algebraic part, x to the fourth. Let's take derivatives. So that's going to be 4x cubed. 12x squared, 24x, 24, and then 0. So we're going to need 6 rows. 1, 2, 3, 4, 5, 6 to continue the pattern. And then dv would be leftovers. If u is x to the fourth, dv is going to be that cosine of x dx. If I integrate cosine, I get sine. If I integrate sine, I get negative cosine. If I integrate negative cosine, I get negative sine. If I integrate negative sine, I get cosine. And if I integrate cosine, I get sine. So we're reading this again. Oops, it keeps moving on me. Across and down, across and down, across and down. So we're going to have a positive x to the fourth times sine of x. I'm going to have a negative 4x cubed times a negative cosine, which would make that a positive 4x cubed cosine. I'm going to have a positive 12x squared times a negative sine, so a negative 12x squared sine. I'm going to have a minus 24x times cosine, positive 24 times sine. And then that's where we would stop. That next one would end up being a 0. And don't forget your plus c. There's one more example I would like to show you so you can see how to solve it. Let's say we want to integrate something like e to the 4x times sine of x, sine of 2x. Let's do that. dx. So if we go back to our acronym LIATE, we would pick the trig part for U. So U is going to be sine of 2x. That means the leftovers, dv, the leftovers are dv, which would be e to the 4x times dx. So let's find du. The derivative of sine is cosine. The derivative of the angle is 2. And then let's find dv. So if I integrate this, remember that's going to be a u substitution. We would need a 4 and we would compensate with a 1/4. So v would be 1/4 e to the 4x. So when I integrate e to the 4x sine of 2x dx, it's going to be uv. So 1/4 e to the 4x sine of 2x. Remember, u times v is the same thing as v times u. I just wrote it in an order that makes it look a little cleaner. So uv minus the integral of v du. Now I'm going to clean all this up. So 1/4 times 2 is then 1/2, and I'm going to pull that 1/2 out. So now I've got that. Okay, but we're going to end up having to do by parts again on this guy. Since I chose the algebraic piece here, I'm going to do the same thing and choose the algebraic piece here. Sorry, the trig piece. Since I chose trig here, I'm going to choose trig here. Cosine of 2x. So dv again is leftovers, e to the 4x. When I integrate cosine, I'm going to get negative sine. And sorry, I said that wrong. When I take the derivative of cosine, it's negative sine, and the derivative of the angle is 2. When I integrate v, remember I would need a 4, compensate with a 1/4. So v is 1/4 e to the 4x. So I'm only doing by parts on this piece. That's important to remember. So this integral is going to be equal to this minus 1/2 times whatever this is. So let's write complete mathematical sentences. You have to write complete mathematical sentences. So carry that first term minus 1/2. I'm going to put a bracket here. So it's going to be uv minus the integral of v du. Let's clean this up. So I've copied everything again. 1/4 times a negative 2 is a negative 1/2. And if I pull negative 1/2, negative negative makes that positive 1/2. I forgot my dx here. I'm going to go back and correct that to write complete mathematical sentences. And I forgot the dx up here with the du. All right, now keep in mind, all that's multiplied by that negative 1/2 here. So let's distribute. So I've got 1/4 e to the 4x sine of 2x minus 1/8 e to the 4x cosine of 2x minus 1/4 times the integral of e to the 4x sine of 2x dx. So check this out. We started up here saying that integral is equal to this. That was the first iteration of by parts, and then we had to do by parts again. So this guy, this left-hand side, is still saying the integral of e to the 4x sine of 2x dx has to be equal to the stuff. Do you see how we have two of those? Now we've got this little equation we can solve. Let's move this guy to the other side. So if I have one of those plus 1/4 of those, that means I have 5/4 of those integrals. And remember, we're still going to have a plus c over here. And then to get this by itself, we're going to divide by 5/4, which is the same as multiplying by 4/5. So if I multiply everything by 4/5, that would get that integral by itself. 4/5 times 1/4 is 1/5. And then 4/5 times -1/8 would be -1/10 e to the 4x cosine of 2x. And then 4/5 times a constant is still some kind of constant. So that antiderivative is actually going to be equal to 1/5 e to the 4x sine of 2x minus 1/10 e to the 4x cosine of 2x. So you see how it took us 2 iterations to get there. I want to do just one more problem. Let's say we want to integrate ln of 2x plus 3 dx. So think about your u here. In this case, your u is going to be that logarithmic piece. So that means dv is the leftovers. Well, the only thing that's left over is going to be dx here. So when I take the derivative of ln, remember it's du over u. So that's my u. When I integrate dx, there's an understood 1 here. To get v, I'm going to get just x. Let me not forget the dx there with the du. So this guy is equal to uv minus the integral of v du. Cleaning it up, I'm going to rewrite this as 2x over 2x plus 3 dx. Again, the degree of the top and the bottom is the same, so we've got to do some long division. So I'm going to have 2x plus 3 dividing into that numerator 2x plus 0. So 2x goes in the 2x one time, and when I subtract, I'm going to get 2x plus 3. So minus 2x plus 3. That's going to leave me with a -3. So I have x ln of 2x plus 3 minus the integral of 1 minus 3 over 2x plus 3. And that's dx. So I'm going to rewrite that. So this is going to be minus the integral of 1 dx. And then I'm going to pull that 3 out. Minus negative would make that a positive 3. 1 over 2x plus 3 dx. So to integrate this is going to be a u substitution. This guy's just going to end up being x. So if I do a u substitution here, think about your u. If u is your denominator, 2x plus 3, then du is going to be 2 dx. So we would need a 2 here, and we would compensate with a 1/2 out here. So now we're in the format where we can integrate. So my rewrite step would say I'm integrating du over u, which is equal to the ln of u. So this is going to be ln of the absolute value of 2x plus 3. And then we're going to have plus c on the end. So there's our final answer.